So here's our time to do some official notes. Pop out those notebooks if you need to. We're going to look at how to solve equations that involve just single trig functions. And we have, like I said, we're not going to use graphing calculators. We're just going to use our brains. So one of the things I'm going to provide for you guys is a sheet that looks something like this. Let me get my face out of the way here. And it's going to have the unit circle on it, the special right triangles, the reminder that cosine and x are related to each other, that sine and y are related to each other. And also the idea that a full rotation around this circle is 2 pi, and halfway around the circle is just plain old pi. So my hope, just as a quick refresher, is that not that you guys memorize this entire circle, but that you're able to memorize these, or you know these special right triangles, and you're able to picture how they fit in the unit circle. And then you'll know that if it's a cosine value, you're looking at the horizontal component, and if it's a sine value, you're looking at the vertical component to figure stuff out. And as I'm working through the example, you're going to see me using that idea. So this will be provided for you. If you don't have it memorized yet, remember, by the end of this year, you definitely want to have this entire thing just part of the things that you know. So to solve 2 sine of x minus 1 equals 0, here's where it's going to be a lot like what you learned back in pre-algebra. Our first goal is to get that trig function to be all by itself. So I want to isolate the sine of x, which means I'm going to add 1 to both sides and then divide both sides by 2. So let's go ahead and do that. Let me pick a different color ink here. Beautiful, not red. We'll add, this is a step you guys are allowed to skip. If you want to jump straight down to sine of x equals a half, I'm totally cool with that. I'm just showing this so everyone feels like at least comfortable with part of this. Divide both sides by 2, divide both sides by 2, and now the sine of x is equal to 1/2. So now is the part where we have to use our brains. And what I want to do is try to figure out any and all angles I could possibly imagine whose sine value is 1/2. And here's how I want you guys to try to process this information. We know that sine is associated with like the y value on a unit circle or with the vertical component. And we know that this is the baby side of a 30, 60, 90 triangle, of that pi over 3, pi over 6 triangle. So what I'm picturing in my head is a circle, a unit circle, where that vertical component is positive 1/2, so positive and small side. So what I'm going to do is, in my head or on my paper, draw this and draw this. These are 2 places where the sine value is positive 1/2, and that's going to give me a triangle like this and a triangle like this. So now I know that this is a pi over 6 reference angle in both cases. And so one of my answers is going to be x equals pi over 6. And another answer is going to be, if this is a pi over 6 reference angle, and I know this is pi, and I take pi over 6 away from pi, I'm going to get 5 pi over 6. That's my second answer. But then I'm supposed to have an infinite number of answers. So this is where the idea of that full rotation came in. Like, not only is pi over 6 an answer, but if I go all the way around and come back to here, that's another answer. Or if I go around 2 times and over here, that's an answer. So I want to add integer multiples of a full rotation, which means I'm going to add to this 2 pi times n, where n is like -3, -2, -1, 0, 1, 2, ... Now, here's the thing. You guys don't need to write this part down, okay? Like, I don't care if you write that down or not. When you're doing math at this level, and people who do math at this level see an n, they assume you mean it's an integer value, okay? But I just wanted to write it down on the notes one time so you understood what the heck's happening out with this 2 pi n. It just means I'm adding a full rotation or some multiple of a full rotation. I'll do the same thing down here. 5 pi over 6 plus 2 pi n. So these are my final answers to this equation. I didn't use a calculator at all. I just had to figure out where on the unit circle the sine value is equal to 1/2. That happened in 2 places. And I want to add these full rotations to my answer. I'm done with the problem. Now, if people wanted a specific answer, then you would have we'll do an example where I ask for specific answers. But this is all solutions to this particular problem. Let's do a few more examples together and see how this goes.